And here we go, ladies and gentlemen, with lessons 6-9 and 6-10, adding and subtracting mixed numbers. Go ahead and pause, check your answers, come on back when you're ready. And so here we go. Where have we been? Well, we've been adding and subtracting fractions, even fractions that go in the negatives. What's next? Adding and subtracting not just parts, but wholes and parts, which by the way is we call them mixed numbers. They are mixed up with wholes and parts. And of course, sometimes we can do so without regrouping, but sometimes we must. Eventually, you'll be able to get into multi-step equations with rational numbers. That is where we're heading. That's why we need this skill, one of the reasons at least. And so here we go. If you'd like, pause, get assignment 23 ready to go and titled. And here we go, folks. So examples without regrouping. Naturally, you cannot add. Let's just look at one example at a time. I'm going to go ahead and put a screen shade up. And we're going to focus on addition, right? So you cannot add fourths with eighths. Those are not the same size slice, but you can add eighths with eighths. Please notice that 1/8 does not change. Meanwhile, 3/4, well, the amount of pizza doesn't change. After all, 3/4 is the same as 6/8. But now we can add 6/8 and 1/8 to make 7/8, 1 whole and 2 wholes to make 3 wholes for our final answer of 3 wholes and 7/8. Does it reduce at all? No, ma'am, no, sir. That is simplest form. Let's take a look at 3 wholes and 1/6, 5 whole and 5/9. We'd like to add these up. Now it's interesting. Usually I write the larger absolute value on top, but we can still do this with addition. It's not a big deal. Now you might notice 6 and 9's not the same size slice, but what is 18ths. Some people will go higher, 36ths, even 54ths I've seen. Now all of those common denominators will work, but we try to use the least common denominator to simplify our lives. Besides, the bigger the numbers get, the more room there is to make little mistakes. 6 times 3, 1 times 3. So 1 times 1/6 is the same as 3/18. 9 times 2, 5 times 2. 5/9 is the same as 10/18. And when we put together the parts, 13/18, and the wholes, 8 wholes, and ask ourselves, can it reduce any further? And the answer is no. Look at how those problems are similar. Look at how they're different. In terms of similarity, of course, differences, they have different numbers. They have different wholes. They have different parts, right? But similarities, they need a common denominator. And in the end, these did not have regrouping. Okay. Let's do a few more just like that. Let's do subtraction. Again, you cannot take away tenths when you have halves. You can take away tenths when you have tenths. Now notice 3/10 does not change, but 1/2, we must rewrite it, cut up those slices into 5/10. That's the same amount of pizza. But now that we have tenths, we have 5/10. We can take away 3/10 and get 2/10. 7 wholes take away 4 wholes is 3 wholes. And by the way, 2/10 does in fact reduce to 1/5. Meanwhile, you cannot take away eighths when you have sixths, when you have eighths. Some of you will go straight to 48, but many of us would prefer 24ths. 1/6 is the same as 4 24ths. 5/8 is the same as 15 24ths. And boom, go ahead and take away the parts, take away the wholes, and ask yourself, does this reduce? So once again, please notice that for all these problems, similarities, differences, top 2 are add, bottom 2 are subtract, all problems needed common denominators. And you know what? We were able to add without having to regroup. We were able to subtract, but I wonder when we won't be able to subtract. I wonder when we won't have enough pieces to take away. Now, a quick refresher on regrouping. If you look closely here, you will find 1 hole, 2 holes, 3 holes, 4 holes, and then 1, 2, 3, 4, 5 parts. In fact, you could say that is 4 holes and 5/6. But at any time, you can regroup and say, you know what, we need more slices. So let's go ahead and cut that hole up into 6 slices. Now notice, we haven't changed the amount of green. We haven't changed the amount of chocolate bar. But what we have done is regrouped the holes now to say 3 holes. And now instead of just 1, 2, 3, 4, 5, we add another hole to it, 6, 7, 8, 9, 10, and 11. But it's still the same amount of pizza. It's still the same amount of chocolate. It's just that one of those whole bars got cut up. Now, if you wanted, you could continue doing that and regroup now into 2 wholes. And now how many slices? We'd have 6, and another 6 is 12, and another 5 is 17. All of those amounts, the same amount of green, the same amount of chocolate bar. You can make another whole disappear. And you could even turn it to improper with no holes. But folks, if anybody says, well, listen, would you like 29/6 of a chocolate bar or would you like 4 5/6? You're going to say, come on, man, that's the same amount of chocolate. It's just that some are cut into slices and the other are not are left in the holes. But that is the entire point of regrouping. It is the same quantity. It's just grouped or cut up differently. Now, keep that thought in mind as we go into the next few problems. If you need to, come back to this page and relook at regrouping. Meanwhile, let's take a look at why this is so important. Once again, you cannot add 8s with 8s. You can add 8s with, you can't add 8s with 4ths, but you can add 8s with 8s. 3/4 is the same as 6/8. Now look, we have 5/8, 6/8. That makes 11/8. And 2 wholes and 5 wholes is 7, but wait a second. That's an extra whole, isn't it? So you can rewrite this as 7 plus 1 3/8. Well, you know what? Let's just mark it as 8 wholes and 3/8. That, ladies and gents, is why regrouping comes in so handy. Let's go on to the next problem and do another addition problem. You cannot add thirds with halves. You can add sixths with sixths. Now, 1/2 is the same as 3/6. 2/3 is the same as 4/6. And now that they're the same size slice, we can put those together. We end up with 5 wholes and 7/6, which can be rewritten more appropriately as 6 wholes and 1/6. Again, that is the same amount of pizza. It's just 2 different ways of representing it. And we're going to prefer a more simple mixed number without an improper fraction. All right, so take a look at number 7. Now, what's interesting with number 7, we're getting into the subtraction now. You cannot take away a third when you have, well, you don't have any parts. But what you can do is regroup 9 into 8 and 1, cut up a whole into 3/3, and write that as such. Please notice that 9 wholes is the same as 8 wholes in another hole. But at least now we have parts to take away. 3/3 minus 1/3 is 2/3. 8 wholes minus 4 wholes is 4 wholes. Can it reduce? No, sir, no, ma'am. It is simplest form. And we finish off with one more problem. And I got to tell you, I can even tell, and you can tell with your number sense, that we will need to regroup because 1/4 is less than 3/5. You simply won't have enough slices, even when you cut them up into the same size slices. Okay, so what do? Well, don't forget, you can turn 7 wholes into 6 wholes and 1 hole. That's still 7 wholes, right? But now take that whole pizza and cut it up into 20 slices. Why are we doing that? Because now we can write it and group it so that we only have 6 wholes, 25/20ths. If it looks ugly, folks, I'm not going to lie, it is. But remember, the whole point of this was to be able to take away 12 slices. Do we have 12 slices now? Yes, we do. So 25 take away 12 is 13 slices, 13/20ths, and 6 wholes take away 4 wholes is 2 wholes. So look at how these problems are similar. Look at how they're different. 2 addition problems up top, 2 subtraction problems down below. With addition, we have to find common denominators. Okay, Mr. Collins, same thing with subtraction. Notice with the 2 problems up top, we ended up with wholes and parts. But the parts were more than another whole, so why write it as kind of a funky mixed number with improper fractions when you could simply pull a whole out, making that 8 wholes and 3/8. Pull a whole out, making that 6 wholes and 1 little slice left over. Now for subtraction, it's a little different. You don't regroup at the end, you kind of regroup at the beginning. If you don't have any slices to take away, cut up one of those holes and now take away. If you don't have enough slices to take away, cut up one of those holes and now you have enough slices. Folks, that's what I have. If you'd like to go ahead and get started on this, coming up will be the answers. If you'd like to take a look at the answers after you're finished, come on back to this video. And here we go with assignment number 23. Take a look, check yourself, bring some questions to class, and let's grow.